So we're going to talk today about visual field defects and specifically about homonymous hemianopia. So if you've got your eyeballs here, they connect to the optic nerves, and then the crossing point is called the chiasm, which resembles the Greek letter chi. Into the geniculate body, the radiations, and finally to the cortex, the occipital cortex. So when we have a visual field defect that's behind this line, the chiasm, you are involving the crossing nasal fiber as well as the uncrossed temporal fiber. And that's what accounts for the field defect that we call a homonymous hemianopia. Homo means same, nymous means name. So same name, hemi means half, an is not, and opsia is C. So same side, half, no C, homonymous hemianopia. And because if you have a left optic tract lesion or any lesion in the retro chiasmal pathway, that will involve the nasal crossing fiber from the right eye as well as the uncrossed fiber from the left eye, and that's what produces this field defect, and in this case a right homonymous hemianopia. And we want to be looking at this field as if we're the patient. So the right side, half no C, a right homonymous hemianopia from a left optic tract lesion. But this same field defect could be caused by any lesion behind the chiasm in the retrochiasmal pathway, including the optic radiations or the occipital cortex. All will produce the right homonymous hemianopia. There are some features that will separate out the homonymous hemianopia, and we're going to go over those features now. The first is, in an optic tract lesion, not only is the visual pathway for the seeing involved in an optic tract lesion, but the afferent pathway for the pupil is also involved. So this afferent pathway for the pupil is trying to go from the optic tract to the efferent pathway for the pupil, which is the Edinger-Westphal nucleus, to the third nerve, and then the ciliary ganglion to the iris. So in the dorsal midbrain, we have what we call pretectal nuclei, and these pretectal interneurons carry the afferent pathway for the pupil from the tract to the efferent pathway, which is the third nerve, via the Edinger-Westphal nucleus. And so if we find a right homonymous hemianopia and have a relative afferent pupillary defect, that is a sign that the problem is in the tract. The other sign that suggests the right homonymous hemianopia is a tract lesion is because we're in front of the cell body that this axon is trying to reach in the lateral geniculate body. Any lesion that occurs before the geniculate body will cause retrograde degeneration, and that we'll be able to see in the eye nerve as optic atrophy. So the presence of optic atrophy and a relative afferent pupillary defect are the signs for the tract lesion. And the specific name of the atrophy, which we don't have time to cover right now, is called band atrophy. We'll save that for another day. If, however, you're behind the chiasm but you don't have an RAPD and you don't have any optic atrophy, then we have to differentiate whether we're dealing with the radiations in the optic radiations in the temporal lobe, or the optic radiations in the parietal lobe, or the occipital cortex. And there are some features that help. So if this is a sagittal section of your brain, from the geniculate body, the radiations travel superiorly in the parietal occipital region and inferiorly in the temporal lobe. And these fibers in the temporal lobe, inferior fibers, are called Meyer's loop. And so one of the features of the homonymous hemianopia that would suggest it's temporal lobe is if the homonymous hemianopia is denser superiorly. So in this particular example, we have a right homonymous hemianopia, but it's denser superiorly, and it's not the same in the two eyes, which we call incongruous. So radiation-related field defects, because they're radiating out like this, are much more likely to be incongruous. That is, not the same in the two eyes. And the same thing for if you hit the parietal radiations. The parietal radiations also will produce a homonymous hemianopia, but the field defect will be denser inferiorly. So this we call pie in the sky in the temporal lobe. So a right homonymous hemianopia, pie in the sky, or it can be pie on the floor. They're incongruous if they're in the radiations. And finally, the cortex, the occipital cortex. So as opposed to the radiations where the fibers are very spread apart, that's why they're called the radiations. In the cortex, the fibers are coming very, very, very close together. And so we can make field defects that are very similar between the two eyes. And so that we call congruous. When the field defect is the same between the two eyes, we call it congruous. So if it's very congruous, that suggests it's occipital cortex. In addition, because a lot of real estate in the occipital cortex is being devoted to the central macular fibers, if we have a field defect that spares the macula, so this little bit of macular sparing here of the field, that macular sparing means the tip of the occipital cortex is spared, and that is also a sign that it is an occipital lobe lesion if you have macular sparing or if it's very congruous. And the last thing that you should know about occipital cortex lesion is, even though we've drawn the fields as a circle, the field is really an oval-shaped field because the nasal field is smaller than the temporal field. That is, there's no correlate for this portion of the temporal field in the nasal portion of the fellow eye. So when we have a right and left eye, this portion of your left eye, in this example, this is a temporal crescent. This temporal crescent is monocularly represented in your cortex. And because it's temporal field, you know that's a nasal fiber. So the nasal fiber carrying the temporal field is traveling across to the geniculate in the radiations, and that temporal crescent is represented right here in the anterior portion of the calcarine cortex, the most anterior portion of the calcarine cortex in the occipital lobe is where the monocular temporal crescent lives. And so what that means is, if you have a homonymous hemianopia, again on the right, if we have sparing of this temporal crescent right here, that temporal crescent sparing implicates occipital lobe. You can also have just selective involvement of this temporal crescent, although that's rare. So the three features that suggest occipital: congruous, macular sparing, and the temporal crescent. So if you just apply the following rules, you'll get through homonymous hemianopia. The lesion is homonymous, it's on the other side, it's behind the chiasm. If you have an RAPD and optic atrophy, that's the tract. If it's pie in the sky, Meyer's loop temporal lobe. If it's pie on the floor, parietal lobe. They tend to be incongruous. But if it's congruous, macular sparing, or you have a temporal crescent involvement or sparing, pick occipital.